Hello, everybody. Sit tight. Gonna get started in about 5 minutes. We'll do an overview, and then after that, we will do some board stuff. And I'm hoping she's not gonna leave. She's not gonna want to leave the room anyway. Where are you going? She doesn't like it when I talk. She hates it when I talk. I don't know if you noticed that, but the cat just left. I had this like super cute cat cam set up. And the moment I started talking, she left. We'll see where she settles down and I can reposition it, but she usually sleeps there when the cleaners are here. She just doesn't like it when I'm talking. She's like looking to see if she can tip over the garbage can. There's an Amazon box here that she could tear apart. She's got plenty of options. Let's say hi to folks. Hi, Bruce. Hi, Mark. Hi, Nintendoodles. Hello, Enki Vanguard. Hi, Emmett Ray. Wiley Kit says, she doesn't appreciate your valuable work. No, she does not. She does not appreciate me. Mark Olson says, you need a wireless cat cam on her, and then we can get a real cat cam. Yeah, from her position. Emmett Ray asks, how are you? I'm good. I've been reasonably productive this week. We'll talk about that. Today was yesterday was a bit of a wash, but I was supposed to play video games with a buddy, but he wasn't feeling good, so I actually got more done than I expected, which is good. But maybe the cat will. Maybe she'll end up. The door's closed, so she's going to be in here, because I assume, we have house cleaners cleaning right now, and I assume that she's not going to want to. I have it on manual focus right now. Hoping that, where is it? The autofocus has just been so bad that I was wanting to get, that looks okay. Drink beer, not water. Johnny B says hi, he's just gone out to a bar. Well, Johnny said he wasn't going to be able to make it, and that somebody he was pre-trolling me that I should do unit tests. And I'm actually going to cover some unit testing I did this week, so I think it's kind of funny. That's all it took. I can try to have Cat Cam follow her. Spook's down in his bed, or in his crate, so it's kind of hard to see him. But that's where she is right now. We'll see if she stays there. Oh, that's the cable's right over my keyboard right there. Sorry. Glad it's not the primary camera that you're seeing that I'm twirling around. There we go. Mad Bodger says, depends on the cat. Our Siamese decided the harness was no big deal. I think they're part Siamese as well, but we do have a video of her in a harness, and she just flopped down on the floor, and my wife just dragged her. It was pretty funny. Yeah, so this is an electronic stream, but we're talking about cats right now. I do like to give people a little bit of time, and I started a little bit early, so I'm going to hang out. I think I am going to try to cut part of this video out as a separate video. We'll get to that later. But for now, now we're hanging out just for a little bit. Charles is here, which is cool. Hi, Charles. Electronic cat, new idea. Yeah, there's actually a company out of Mexico called Electronic Cats, and they made a meow, a cat-shaped board, which was cool. He refused to eat as a kitten. They generally don't have a problem eating. But Spook has a little bit. Yeah, he's in his crate. It's kind of hard to, it would be hard to get a camera on him. So it's Vin week this week. All right, I'm gonna start in a minute here. Oh, you know what? I should adjust this. Stream settings. It should be good. Like the latency should be good. I remember to switch that. I think I've remembered to. Lower that all the way down. Oh no, people are leaving. Emmett Ray says, do you know when we will see an Adafruit BNO080? I don't know the exact timing, but I know that I believe that Sedacious is working on it. So when it's ready. Hi, Mr. Certainly, and hi, David. Glad you could both join me. I do have the overhead set up here as well. It's obviously not focused. But this is a clue as to what we're going to do today. Oh, it focused on itself. That's no good. It like reflected. There we go. That's better. All right. Let me get going. I don't want to get so many people upset that I'm just talking about cats. Switch to here. Hello everyone. My name is Scott, and I work on Adafruit. I work on CircuitPython for Adafruit. CircuitPython is an easy version of Python designed for microcontrollers, which are small, inexpensive embedded computers that they look like little chips on stuff. You may have experienced those in a thing called Arduino. Arduino has a lot of development boards, which is like the board itself that has a microcontroller on it. This is my deep dive. I do this every week while I'm thinking of it. It's normally on Fridays at 2 p.m., which is what we're at now. That's Pacific time because I'm in Seattle. So I'm on the Pacific coast of the U.S. And I also wanted to say the next 2 weeks will not be on Friday. Next Friday or next week, I will be doing it on Thursday because the weekend is a long weekend. So we're taking Friday off. My wife and I are. And then the week after is the week of CircuitPython Day, which is on Wednesday, September 9th. So my plan is to do, and they're at the same time, but different days. So my stream now is, next week will be on Thursday at 2. Seems that your camera is normally more focused than it is today. So I have it on manual focus, and maybe I just need to adjust it. This way. I just don't like that it like seeks. Is that better? I'm trying to do it just based on the. I think I went back past. The problem is I lean in. How's that? Is that better? The problem is that I lean in to adjust it, which moves my face. I'm considering splurging on a different camera that. So let me know. I know that there will be a bit of a round trip. Let me know if that focus is better. I can adjust it. It's good enough, as long as your code is not fuzzy. No, it shouldn't be. But did that improve it? I'm trying something else because like if it's on autofocus, it like does really like lots of seeking, which is really bothering me. But that's the thing. That's the reason I think I want to get a different camera. So yeah, so next week, I will not be on Friday. I will be on Thursday, and the week after I will be, my eyes look like Don Jr.'s. It's a nice soft focus, like Vaseline. Really? It doesn't look that bad. I could make it bigger on OBS and my wrinkles are gone. I could also turn autofocus back on. See, so that's behind me. That looks about right to me. How's that? You won't look at me big for a while anyway, so I should not worry too much about it. But I'm experimenting at it. Okay, so yeah, next two days are not on Friday, so heads up to that. I did put it in the YouTube description, so that should be up to date already. One is on next week is on Thursday. The week after is during CircuitPython Day on Wednesday, so that's going to be a very busy day. So yeah. Oh, Vin is in focus. Yeah. Yeah, Spook's in his bed. That's the other cat that you're seeing. So housekeeping, Adafruit.com if you want to support me and support Adafruit to make open source hardware and open source software, including CircuitPython. And if you want to join our Discord chat, which lasts all week long, all the time, you can go to adafru.it/discord. That will get you to our Discord server, which the chat won't disappear over time. I didn't see anything come in on the Twitch chat, so if anybody's watching there, could you just drop a note in the Twitch chat to make sure I have that working? I do not have it on the screen, but I do have it pulled up for myself. The other thing is just the warning about spook seizures. So both cats are in the room. Vin doesn't want to be on camera, obviously. Spook's in his bed down here that you can't see with the normal cat cam. He is epileptic, so if he does have a seizure, I may pause and take about a 5-minute break just to make sure he's okay. So just a heads up with that. If you wonder like why I'm not even in the shot, that's usually what's happening. She is now down behind me. I don't know can you see her? That's the wrong chair. She's like literally like right behind me. The worst spot. Maybe we could see her that way. There we go. She's under the chair. Okay, so that's the housekeeping. I don't think I forgot anything. This stream goes for about 2 hours till about 4 p.m. Pacific. And what I tend to like to do is I like to do about a half an hour of like kind of everything that's on my mind. Thank you, David, for saying Twitch is coming through. I see that. And then I have like kind of an hour and a half at the end that I want to do something specific. So the something specific I want to do today is add support for the Kaluga. If I go to the overhead here, this is the Kaluga. It's another dev board by Espressif. It is not, this is the Saola. They're both by Espressif, but obviously the Kaluga's got a lot more going on here. And we don't have a board definition in CircuitPython yet. And now that we're getting more and more into CircuitPython and more people are wanting to make boards, I thought this would be a great opportunity for me to just walk through how to add a new board. So we'll do that and hopefully get that out today. That shouldn't be too bad. Hi, Ordum. But before we get to there, I think I want to try to do that kind of like a little bit more formal, because I may want to actually split it out as a separate video so that I can link people right to it. And then let's see, what's the final thing? Oh, but before we get to the Kaluga stuff, pressing the buttons, I want to just talk a little bit about a couple of the things that have come up. David says, which camera is attached? What this camera is, I'm not sure. We'll pull up the Kaluga datasheet later and take a look at that. So I'm not sure. It just came with it. It actually also comes with this like touch PCB as well. Mark says, get a PTZ cam for the cat cam and let me control it so you can focus on the stream. Yeah, the problem is then like you need one that can like roam around. Let me switch to the desktop. So I've got my browser here, and you can see that we are actually carrying, Adafruit is actually carrying the Kaluga now. It's pretty pricey, and that's because it comes with all these different things. But it comes with the Rover, which is includes the PSRAM, which actually was merged in, so that should work now. Although I heard some reports that SPI is not working for folks. So, and this speaker might, I don't think mine had a speaker. I didn't get mine from Adafruit though. I got it directly from Espressif when they were first doing it. But yeah, it comes with a lot of stuff. That's why it's a bit pricier. It comes with a screen, which I'd like to get going today. The camera I'm not going to get going. The touch stuff I'm not going to get going. But it would be nice to get actually CircuitPython going on the screen, which is maybe a bit ambitious given that I don't always get a lot done during the stream. So that's a teaser that's coming up. But first I want to talk to you about a few other things. Hi, Unexpected Maker. There's also this, we'll follow this how to add a new board to CircuitPython guide. It might be a little bit weird because we're doing an ESP board. Also available through DigiKey. Yeah. So first I wanted to say I actually got the native Wi-Fi API PR out. It is a long time coming. You can see it's a lot of commits. There was some stuff I had to fix, like the stubs and the dock builds were broken, so I had to fix those. I came up with what I hope to be the final partition scheme, and then these are just two fixes. But let me just go over this a little bit. We wanted to make room for a. Let me make it bigger. So here's the diff. You can see that what I used to have it set out as is OTA data. This keeps track of like which of the two flash sections we should use, and then Phi init and user FS. So this is where your like CircuitPy drive lives. And what we needed to do is one, I wanted to make the sections, the OTA sections bigger. Mark Olson says, never ever write hopefully final. It'll change for sure. Yeah. I'm digging a hole for that. So I wanted to make the OTA sections bigger and also add space for the UF2 bootloader. And so what we have here is the revised version, which is OTA, Phi init, and then the OTA sections, but they're like non-trivially larger. What that was. And then a section for the UF2 bootloader. Like all of the IDF stuff tends to be gigantic, so 256K. And then actually just under a megabyte for the user file system. I'm really kind of very worried that we're going to run out of space for CircuitPython in these OTA sections. So I was willing to go under a megabyte for the user file system. Now on boards like Unexpected Makers, Feather S2, where I believe it's 8 megabytes of SPI flash instead of 4, then this will be 4 plus 960. So that's how we would do it. Although we could vary the partition layout per board because we do have builds per board as well. So yeah, if folks want to test it, please drop a note on the PR. 16 megabytes. Oh, I was wrong. Even better. Even more space for stuff. So yeah, this should be ready. Dan is reviewing it. He hasn't taken a look yet, but it's a lot of code, so I don't blame him. He's also doing a release today, which is exciting. But yeah, if you want to try native Wi-Fi stuff, check this out and drop a note saying it worked or it didn't work. We'll probably want to get it in anyway and then just follow up with fixes after that because it's much easier to do small things. The next thing I want to show is actually a Twitter. So switching gears. I'm trying to snag it out of this tiny. I should have had this open. I'm sorry. Wow. So one thing that's been like people have really wanted for a long time is with development boards, you don't always, here we go. You don't always want to include like an SWD connector, but in case you need it, it actually is like really handy to have. So there's this SOIC byte thing that people have come up with a while back. Bruce says, I saw something where Espressif will be removing many components from the IDF and have a component manager to select what you need. Yeah, I mean, there is a component manager, like in the sense of, like there's menu config and then there's what you put in the CMake lists as well. But we can fix the size. Like we can certainly make it smaller. It's just going to be some work when we get there. Anyway, so there's been this problem that like, how do you have something on your board that costs nothing, but makes the debug stuff more accessible? And I had seen this thing, I guess, last year called SOAC byte, and it reuses this connector that's usually on top of like a SPI flash, and then they put it on the side of the board like so. I'm just digging a big hole for myself, aren't I? I just said hopefully final, and we can fix it later for the size. Yeah, big hole. You know, it's fine. We can make do. And this is almost awesome. Almost what I want. Because it's zero cost for the board itself. It just takes up some area. And then you need a connector. Unfortunately, you do need to adjust your SOIC 8 test clip. And that's the bit that's just a bit that's like hung me up on this is like, I don't want to have to like clip plastic parts off of the connector. And so I saw this go by from this person on Twitter. I don't know. Takanaririn. I don't know how to say it. Somebody I follow who does awesome stuff, but had say like the clamps aren't working out. I just soldered to it instead. And so I replied like, oh, I've been like trying to come up with a better connector that you don't have to modify at all. And then Greg Davil, who's kind of like notorious for soldering crazy stuff and taking really good pictures of it, says, what about these things, which I happen to have here? And what these are is they're typically used in linear LED strip lighting. So you're making a big installation out of a number of PCBs, and you like use these connectors to go from one board to the next board. And the PCB thickness is 1.6, which is what your typical boards are. Only the smallest Adafruit boards are actually like half that. Mark Olson says, I'm literally right now making a new board that the SOIC byte connector will be perfect for. Bruce says that's very neat. Well, hold your horses, because I think there's a bit of a... Yes, I can send you the link to this. So I'll put it in YouTube as well in case somebody wants it. And I think I do. So the YouTube is white now because I have it open in a private window in addition to the one that I can moderate. So hopefully if something comes in I need to moderate, you won't actually see it. But yeah, so this is a pretty neat connector. It is available in 4 sizes. It's available in a 4-pin, a 6-pin, an 8-pin, and a 10-pin version. There's a 4-pin here, a 6-pin, 8-pin, and a 10-pin. And it has this like notch to it. So there's a key here. So there's like only limited amounts of orientations that you could do. Bruce says, I'm very interested in the CAN work being done in CircuitPython. Yeah, I've had some discussions with Brian and Jeff about it. If you're interested in it, make sure and chime in on the issue for it, because we are looking for people who've used CAN who understand what they want to use it for. Oh, interesting. Unexpected Maker says all my boards are 1mm. Interesting. Yeah, I that's a bummer. I didn't realize that. I feel like I've looked at edge connectors and 1mm. It was M2. The M2 edge connector is 1mm. Yeah. So these are 1.6, which I think is pretty typical, but I could be wrong because I don't actually measure all that stuff. But in terms of OSHPARC, like the standard OSHPARC order is a 1.6mm board, which these will work for. I don't know if the SOIC byte works for other things as well. I don't think so. There is a thing called Tag Connect, which is like the commercial version of it. But it's like a very, I mean, it makes sense, but it's a very fancy connector because it's got like spring-loaded pins and things like that. So this is the thing that commercial folks use, but I was hoping to come up with a version that has no cost impact, which these don't. They don't have any cost impact to the boards themselves, and the connectors are cheap and available. So yeah, Mark says M2 is 0.8mm, whereas JLC standard is also 1.6. Yeah, maybe we can come up with a way of making a 1.6 or a 1.0mm board fit, but I haven't gotten that far. Yeah, so there's this thread on Twitter, and it actually, let me show this stuff. So there was this project here that basically was trying to use them in a lot of ways, like we're doing, in a lot of ways, like Adafruit's now doing stemma stuff. Unexpected Maker said it would just be a great way to get extra I/O or SWD out by using small pads like you're looking at doing. Yes, no cost impact, just board real estate. Yeah, and actually on the board real estate size, if you look at these pictures, it's actually not that small, because the pads are 1mm and they're 1mm apart. So it can, if you do the full 10 pin, it's actually not the tiniest thing. So it's like 4.5 by 4mm. Yes, so that could be a problem. It is double-sided as well, and there is the slot. So Timon says I designed an open source replacement of the Tag Connect. You should send me a link, Timon, and I'll pull it up on Discord. Or you might be able to post links on Twitch as well. Yeah, so you can make the mating part yourself. Yeah, see, I don't have a 3D printer. I wanted something like if you... Okay, so let me click into this because I think this is... Yeah, so if you buy it from DigiKey, the 10 pin is just over $1 in singles. Oh, it's just PCB based. Yeah, you should send me a link if you have a link for it. But yeah, so you can get it for $1.06 in singles off DigiKey. It does say that it's only 5 mating cycles, but it's also rated to be like 3 amps. So what we're thinking is that you can use it for a lot more mating cycles. You just won't get the 3 amps out of it after those first few. But we have a big, long conversation about this. So Chris Daly has been helping pick up and ran with this idea along with me as well. But basically, we've come up with a spec for this footprint. And unfortunately, this is a giant thread and I don't know where everything is. But I got the domain debugedge.io. All right, Yes, I can see the link. So here's the pinout that we've come up with, and the goal is that you can actually do just the first 4, and it will work, but you have to bring your own 3.3 volt power to it. The idea being that like power and ground are usually things that are broken out over other pins. So if you just need like a small footprint for the SWD side, you could just do the first 4. But the 6-pin version has the power as well as SWO. And then you get JTAG with 8 and you get Trace with 10-pin version. So the idea is that like the board itself, the target can have anywhere between the 4 to the 10 thing. And then the thing that you're connecting it to, the host, will have a full 10, but then you can just slot the different connectors on top of it. So that's what we've been doing. Let's check out Timon's thing. Which I hadn't seen. Osh Connect. Nice. These holes can be fitted with an assortment of polka pins and other tubes. So look at that. And then how does it stick? Oh wait, let's see. There's more. Interesting. Here's another one. Then they're not compatible with a retention clip. Yeah, so this is something that people are definitely trying to come up with. Interesting. Huh. I tried to retain the retention system they have. Yeah, so we're experimenting with this edge thing. Mark says you should really use TX and RX on it also. That's better than SWO. I think TX and RX are more likely to be broken out by other pins. That's why I'm thinking that it's just SWO. Bruce S thinks Osh Connect sounds like an insurance company. I like the advantage of these two systems is that you can put them in the middle. The edge of the PCBs tends to be actually pretty valuable space. So I think it's good to have multiple options for sure. So where do we end up with the Debug Edge stuff? So this is the pinout, and you can go to Debug Edge IO. It's supposed to have a theme, but I don't know why it doesn't have a theme. And I mean to actually elaborate on the different pin configurations. I think I might put it on a board that I want to do for the FPGA stuff. Let me. There is an OshPark version. So Chris, what the heck? It's loading. Chris whipped up an OshPark version. So we do have the repository, Debug Edge, and Debug Edge IO. So this is the website if you know Jekyll and want to help me with that. And then this Debug Edge has KiCad files for the footprints and stuff. Order details. Really? I can't just... How do I find... Mark says, I can fix the website. It's my thing. Anyway, so let me show you this. So this is just all my order history. But you can see that here's the like target side and then the host side as well. And then this footprint is the SWD footprint. Right. The other, I was poking fun at their patent. And then I was thinking what would be cool is that it would be cool to actually like have a bit of a design to this edge, so it didn't just like any sort of edge connector. Kind of to, because I think part of the problem is just like branding, which turns out to be very important, and Adafruit's really good at it, and they succeed because of branding and everything else. So that's why I like grabbed the website, grabbed the like GitHub organization and stuff. But I was playing around with last night. I was playing around with it, like tweaking the footprint to make it more obvious that it is something unique. And so let me move my Twitter out so you can't see everything on my Twitter. Ooh, I'm running out of time. Here we go. So I was playing around with it, and so what I'm gonna try, I did is I slanted it a bit from the two core ones. So even if you get just the 2-bit, it'll be a little different. And then one side I also want to, one side I'm also having silk screen, or I think I'll have an After Dark version that has like a copper pour in between the gold things as well. Mark is pitching RX and TX. Yeah, I mean, we could put those on the 10th. We could make RX and TX on the 10th side because I just have trace there. And we could just say that like it's either trace or RX TX. We could do that. But I really want to have open source trace support at some point. That's why I did that. Yeah, not against changing it later, but at some point we should. So one thing I did is so for the host side, I want to have the ground pin shorter, and then the target side will have it longer to kind of like evoke that you're plugging it in that way. And hopefully making it kind of unique and obvious that it's kind of like a standard. Okay, Mark agrees with the trace/uart. Yeah, we could do that. I have to put the SVG file for that for the pinout, but I could do that. Okay, so that's one thing I'm working on. I got really distracted by it, but I think it's really useful. Like I try to get Lamore to put these SWD connectors on the boards, and she does usually, especially if it's large. And then she can decide whether to place it or not. But the problem with that is that people have a hard time soldering these down. And so if we could do more of like this edge system, then it's solder free as well. And the tag connect and the open source connect, and those are solder free as well, except to make the connector. Anyway, yeah, making it solder free is a bonus as well. But yeah, I want to do variants for like host and target, and variants for like the 2, 4, 8, 6, and 8 and 10 pins, or not 2, 4, 6, 8, and 10 pin variants as well, of the footprints. So that'll all be in like an open source KiCad repo for those footprints. And if somebody wants to make footprints for other stuff, you're welcome to do that too. Okay, let's go through here. Yeah, it's an interesting problem. This is unrelated. So that's the open-ended connector stuff. And I have these data sheets open, which I don't use. So the other thing I just wanted to talk briefly about, and I think troll Johnny a little bit on, is that he said earlier this week, like, oh, I can't make it this week. Like, I hope somebody else there is there to heckle you about not unit testing anything. And I wanted to say, I actually realized that unit testing would be really helpful for the requests stuff that I've been doing. So if we look at my requests, so I did a lot of changes to this. One, to try to reduce the like maximum memory usage, but also to support HTTP 1.1, which includes chunked responses. Mark Olson says you really need the unit test. Yes. So I decided to add unit tests to requests, which would be a way to get for me to be more confident that I'm like safely evolving the Python level of the networking APIs. One of my goals with the request changes I made as well is to actually get it to work with CPython socket. Which I'm not actually using for for testing. I just have a mock it is what I called, which is what I called it. So Kattni just merged it in, but I did a pull request and I added just some basic tests. So I added a workflow file to run them using PyTest. I added some lint stuff, and then I had these sorts of tests where you can say like return get address returns this. I made a mockit class or module with a mockit class that basically is a kind of like a socket but set up with mock methods for the things that we use, and then you can kind of tell it what to do or what to append. You call kind of the library as you would, and then you assert that certain things happened. Here's the mockit class. You can see I'm using like Python standard mock, and I kind of lay out all the bits of mockit that we use, and then make read line and receive work kind of by you give it the response when you construct it, and then it like will return the little bits of it there. So yeah, I'm starting to unit test. I figured out how to run it in a CI, and I actually realized that some of the we have a few libraries that actually had unit tests, but they weren't running in CI. So I added configuration to those libraries as well, so that they would run too. Any questions about any of that stuff before we move on to the Kaluga? Let's get those out of the way if we do. I think my next step here is to take my HTTP 1 branch that I have and get the test working with that. And then I think what I might have to do is actually create receive into and all the different socket implementations we have for like cellular and Ethernet and stuff like that. So there might be some smaller PRs that need to get in for that to work, which is okay. Naomi Bear says, oh, sweet, you're using Plasma. Yes, I'm using KDE. No questions. The cat is scooted over a little bit. Let me move the cat camera and then I'll... Maybe you can see her here. Underneath the chair in the sun. Okay, so let's move on. So yes, I was working this. I was actually thinking I would be doing unit testing today, but Lomore added the Kaluga to the store. They have a bunch and they're in stock. And then so she asked me like, oh, we don't actually have a build for this. And I was like, oh, I could do that. And then also somebody on Twitter, my life like revolves around Twitter now, which is arguably a good thing or not. There's this post. So this will be a good transition. Cat cam away. Okay, so this person, Remy, said, I'm a really big fan of the ESP32-S2, and I can't wait for it to be fully functional on CircuitPython. I think I got you, David. Thank you for reminding me. Thanks to the amazing work of myself and the community for adding support. I just received a Nano ESP32-S2, and I'll try to contribute to it if I manage to understand how. So yeah, I think I may have done it. I think I did the Feather S2 on stream already, but I just wanted to give myself another chance. So maybe let me restart what I'm doing. Because I think I do want to like actually section this out as a like explicitly like here's a video about how to add a board to CircuitPython. So stick with me. I'm gonna do it as an intro here. I've kind of been inspired by Peter Esden Temke has been like Esden's been doing like his long streams, but he's doing community news and separating that out, and I like that a lot. So I think that's a good idea. Bruce says, so anyone can do a pull request for a new board, even not the manufacturer. Yes, for sure. Yep. So yeah. Let me summarize what we're going to do because I'll chop this bit out. And then if you have questions and stuff, I think that's fine. I think it'll still be the deep dive format. Hello, everyone. My name is Scott, and I work on CircuitPython for Adafruit. This is a section of my deep dive that I do on Fridays at 2 p.m. Pacific. If you want to know more about CircuitPython, you can go to circuitpython.org, check out my deep dives. We've got lots of different topics, but this is a section of a deep dive that I thought would be super useful for folks, and so I thought I'd split it out. If you want to support Adafruit, they pay me to work on CircuitPython, so you should support them. You can go to adafruit.com. If you have questions about anything you've seen in the video, I try to keep track of the comments, but the better place to ask them is Adafruit's Discord server, which you can join by going to adafru.it/discord. What we're going to do in this section of the deep dive is we're going to add a new board to CircuitPython. We're going to add an ESP32-S2 board to CircuitPython. It's very, very easy because much of CircuitPython is specific to the microcontroller that's on the board, and then it's just a matter of pin out and features of the board. So what I'm going to do now is add the Kaluga board. So let me switch to the screen here. So here's somebody doing the Nano ESP, or talking about the Nano ESP32-S2. This is a board that we do not currently support on CircuitPython. Somebody's saying, oh, now you got to demonstrate that it's very, very easy. I think it is. Adafruit just started carrying the Kaluga dev board, dev kit from Espressif, which is a larger board here. It's very fully featured. We're selling it for $55. Let me switch to the overhead and show it off. Chapstick for scale. Chapstick for scale. We have that, and then the Saula here is the inexpensive version of the dev board. These tend to run $8, while the Kalugas have screens and cameras and all sorts of stuff, all sorts of bells and whistles. So we're going to add support for the Kaluga today. And we do have folks in the chat, so if they have questions about boards, we'll cover those as well. If you want to know what boards are supported by CircuitPython, let me switch back to my screen. You could go to circuitpython.org /downloads. That will get you there. So this is a list of all boards that are supported by CircuitPython, and they're ordered. You can see that we have 148. And they are ordered by the number of downloads that we get. So every time that we update this page with new versions, we rerun a script that keeps track of how many board downloads each board got, and then we sort this page by that. So you can see that there's a number of Adafruit boards here, but there are also 2 Seed Studio boards. And then if we scroll down, you can just see that there's lots and lots and lots. One thing I'll say is that if you ever are interested in getting the boards photographed by Adafruit, I think we are happy to do that. So you can send us a copy and we'll take it if you want it to be a bit more consistent here. But we're happy to have them all. We love collecting them. You can see that we have like discovery dev kits and stuff here. So 148 boards currently supported, including ones like my Game Boy cartridge that I have like one copy of. So really, we're happy to have any boards in CircuitPython. Having a board in CircuitPython means that it will constantly get updates as we release new versions of CircuitPython. So by having your board in the central repository, we will auto-release new versions of CircuitPython for it. This is a brand new one. I like that background. That's like a DigiKey background. The Micro S2 by Microdev. It's down at the bottom because it was just added. It has no downloads yet, but that will change. Ftdi, you can always watch the show later. But yeah, so that's how you can check out boards. The other thing I guess I should point out here is a relatively new feature. If you click into the board, you can see a description of the board on the left, including like links to tutorials and places to purchase it. So it's totally okay if like it's not available by Adafruit, you just sell it yourself. Like happy to have it there. There are kind of three versions that at most that we can show. The first is the stable version, and this should be uniform across all boards. There's a couple boards that are weird because we no longer support them, but generally everything will be up to date. And then the unstable builds are the second thing here. And you can also see that it will tell you all the built-in modules that are available in that board. And then absolute newest is a way for you to get like literally the latest commit to the main branch of CircuitPython. You can click Browse S3 and you'll get to this giant listing of things. These are extra old versions here because we now split them out by language. So we could just do ENUS. And Lady Ada just pinged me on internal Slack saying, "Did you end up making a PR for the Kaluga?" Let me let her know that I'm doing it right now on stream. Maybe she'll tune in. I don't know. Okay, so yeah, this is how you can get the absolute latest. So after you've added your board to mainstream to the main branch of CircuitPython, and it's not available on those top two things of the website yet, you can still get it with this absolute latest S3 thing. These are all automatically built in the same way that they're built when they're released. And then, is there anything else interesting about this page? Past releases, they take you both to the S3 and the GitHub. And we do have links to UF2 bootloaders as well, which I'm not sure where that comes from, but we'll want to add that for the S2 stuff soon as well. Okay, so how do you add a board to CircuitPython? Well, we have a guide for that, which is great. So I will put this in the descriptions, the link to this guide in the description of the video, so you can check it out. It is titled "How to Add a New Board to CircuitPython," and it walks you through that. It will be 149. Yeah, she's probably excited to get to 150. Okay, so let's see. Let's just follow this. This guide assumes you're using a SAMD21 or SAMD51 microcontroller board. We also support the NRF52840 and possibly more chips by the time you're reading this. And the process is similar. So it says the following files must be updated. The board name folder will be your board. The first three must be customized for your board, and your board must be added to the list in the fourth thing. Okay. So let's, there's a link to the build process. We know how to do that. Let's do the branch stuff. So This is totally unrelated. Okay, so we're in our native Wi-Fi branch, which we don't actually want to be. So the first thing you want to do whenever you're starting a new... hi, Brian. You always want to fetch from the latest. And then check out... You can see that we had a new release since I last fetched. I'm going to check out Adafruit main. I highly recommend always naming your remotes off the people that are, or like the organization that the remote matches. I do not like origin and upstream because they're vague. So I recommend doing it this way. You can see that once you have more than those two remotes, it makes a lot more sense to name them based on the CircuitPython stuff. Because, you know, I may want to pull down from MicroPython, or I may want to pull down from our version, Adafruit's version of CircuitPython, or some of the other folks that work on it. So I've checked it out. I've checked out main, and now I'm going to do switch C to get add Kaluga is what I'm going to call it. All right, so let's go back to the guide and say, okay, create a branch. We've created a branch. Let's keep going. So to demonstrate, this guide will walk you through adding a board similar to Trinket M0 called the Pi Ruler. DCD, thank you for the link in Discord to this guide. So those who want to follow along and tell me when I missed a step can. I'm actually going to, like, we're adjusting this for the ESP32-S2. So I know that the Kaluga has the rover on it. And in fact, let's just confirm, I don't think there is a room version. So let's just pull up the manufacturer's page about it. ESP Kaluga. Look, I've been there before. Let's see what it says. So the ESP32-S2 Kaluga kit demonstrates the human-computer interaction functionalities. So with the Sala, there's actually like two versions that you can get, but I think in this case, it always comes with the rover on it. I don't think you can get it in the room thing because it has a module, and it explicitly says that it's a rover on the module here as well, which means that we can actually omit it from the board name. So the first thing I'm trying to come up with is what is the name of the folder that I'm going to make, and kind of what am I starting with. So yeah, you heard the vacuum. Yeah, the cleaners are outside. Okay, so we're going to change to the ESP32-S2. Always do git status, and let's just update everything here to get a fresh, clean status out of it. Submodule. So when you do a switch, it doesn't update the submodules. So that's why I'm updating them specifically. So now I only have one left. So now my prompt's turned green, and we're ready to get going here. The reason is we're not actually including the Wi-Fi stuff in this because that's not checked in yet. That's why I had to switch that over. So the next thing we're going to do is we're going to copy boards, and then we're going to do Espresso Sala Rover because it's the same module. So I think that's the best thing to start with. So we're going to do boards, Espressive. So we've been bad about doing this in other ports, but I think it's going to be more and more important as CircuitPython gets more popular. So every board name that comes in for the ESP32-S2, I want to have the manufacturer as part of it. So even for the Adafruit stuff, we'll do Adafruit _ because I just fully expect us to have a lot of boards. And we already had one that was called like a Micro S2, and that's pretty generic. So I asked them to add their manufacturer in front of it as well. So we're going to just call this the Espressive Kaluga 1. And because it only comes with a rover, I'm going to ignore that. And it's going to complain. Okay, so let me pull up my text editor. It is on the Mockit request stuff, so I'm going to have to switch projects to CircuitPython. And in fact, I think what I'll do is I can actually close others. And I'll just close everything. Kind of start from a clean editor here. So if we look at here, I'm in ports ESP32-S2. And I'm going to look in the boards directory. And now there is an Espressif Kaluga 1. So I think we're caught up to the guide. And I kind of want to follow it, even though I have things in mind that I want to do, but I may not do them in the same order. So let's just go. Let's follow this guide some more because references are good. Okay, so this says, take a look at existing boards available in CircuitPython and choose the one that is close to yours. Okay, so we did that. Match the microcontroller, match the external SPI flash, does it have a crystal? Additionally, with the ESP32-S2, if you're like this case where you're using the rover or the room module, that can be a really big clue on where you want to start as well. Okay, so we copied it over, and now it says the first thing you want to do is verify that you can build for your board by making the most basic changes possible, building it and loading it. So these are the first things we're going to do. So we're going to update the board name, which is in board np config board. So let's do that. np config board, and let's just call it the Kaluga 1. Okay. Chip variant is going to be the same. SPI flash is going to be the same because it's in the module, and the crystal is going to be in the same as well. The hardware NeoPixel is likely on a different point. So one thing that's really handy to have is the schematic as you do this, because a lot of what you're going to be doing is just adding like human-friendly board-specific names to pins. And so let's just take a look at the Kaluga schematic here. There's also this pin mapping Excel that we may want to take a look at too. There is a lot going on. So hopefully we'll be able to at least, like, I'd love to get the screen going. We've got an hour. Fingers crossed we can get the screen going. So, but first I want to just look for an RGB LED, which we can see here. Let me zoom in. So this is a schematic. Basic tips for knowing how to read a schematic. Here's the module, and the names in red and green here are the names of like the wires, the nets is what they're called. And so if the names are the same here and in another portion, that means that they're connected to one another. So what we're going to do here is we just see that so RGB LED, and then it says put jumper on if you want to control the RGB, which is the jumper GPIO 45 goes to RGB control. Now, I think that 45 is one of the weird ones that you don't necessarily want connected at startup. But let's kind of inspect the board here. This is not going to be, my deep dive videos are not super short, but hopefully we're following along still. So let's just switch to the overhead here. And actually, maybe I'll turn the room light on as well. Give me just a bit better lighting on there. So let's take a look at what we have here. So I think there's 3 layers here. For one, we have this camera, and I'm actually just going to remove that because we don't have camera support. So let's ignore that for now. Here's what the board looks like. I just don't know where everything goes. Okay, so I'm going to remove that and set that aside. And then at the top layer, we have the screen. And if we look, we can see that there's 3 layers here. So I think what I want to do is I just want to like take these layers apart. Unexpected Maker says, yep, 45 is strapping pin. So what we have to be aware of is, so there are 3 pins on the S2 that change the behavior at startup. So before your code runs, there's ESP IDF code that runs. And that can change the way that it talks to like the chips, like the other chips that are in the module. So you have to be very careful. Like one of them changes the voltage to the RAM. So you have to be very aware of that. You have to be very careful. I made the mistake on my first rev of my adapter board that I put I2C on it, which pulled up something that was normally pulled down. And it's bad news. Yeah, and Unexpected Maker says it's the VDD SPI voltage set pin. So if the NeoPixel or if the RGB LED influences the state of that pin, we could be in trouble. So let's just take a look. And one thing I'm curious about is whether, like, I haven't changed anything on this board. So I'm curious to see if that jumper for the RGB LED is set by default. Okay, so I popped that off. Here's the back of the screen board. And if we want the screen to work, we're going to have a pinout for that. Here's the second one, and I think this is an audio board. We can see this is a headphone jack here. What's it say? Yeah, I think it's an audio board. Yeah, this is labeled speaker. Page 16 of the data sheet. Yay, people are following along. Talking about the strapping pins. All right, well, we got to get it down to the most basic thing. Start simple is what the guide has us do, and it's a great idea. So start simple. There's also all these buttons. So we'll probably want to, and they're labeled record, mode, play, set, volume down, and volume up. So we'll probably want to have like pins that are named that. So let's just pop that off. I'm trying not to bend the pins, but I always end up doing it anyway. I didn't do too bad of a job. Nothing on the back of that PCB. Okay, so we're down to the bread and butter, and this is probably one of the most complicated or complex boards that I've worked with, because you can see that these are all switches for different settings here and here. They're covered in these this Captain tape, which you can actually just remove. The reason the Captain tape is there is that when it gets picked and placed, so when it's placed on the board, they use suction. And without there's no flat spot. So you have to put tape on it to get like a good suction to pick and place it. You'll see it also on like USB connectors sometimes. And for all these little switches, tweezers are your friend as well. They make it much easier to flip. Winston says, interesting product. Yeah, this is definitely the more advanced thing. So I can move my audio here. So just to go over kind of what we're seeing, is there a best way to orient it? I don't know. It's for me, it's this way. But I think that flips it. Let me flip it for you. Like that. I think that's right side up. Tell me if I'm wrong. So just taking a look at this board, this switch set is labeled JTAG. Here's the module. This is where all the brains are, so to speak. There's 2 switches here, which are not labeled, but this FPC, it's a flat connector. I don't know what the P stands for. So there's a touch FPC connector here. There's an I2C FPC connector here. This says 3.2 inch LCD FPC connector. This is an Ftdi chip, so this is talking between the USB here and the UART here. That's similar to the USB on the connector. CHR, I don't know what this is. Here's our RGB LED with a jumper, and you can see that to answer our question, the jumper is set, and it's labeled WS2812 at IO45. So we'll give that a shot. We'll update that. And what else? This is reset. This is boot. And they're right angle buttons because you're going to have stuff stacked on. And then the last thing was to look at the labels here. And they're labeled with just the IO names. So those are going to be the same. Some boards will change them to like A or D. And so when you're doing your board define, you would want to change it for that. So the other thing that we have to figure out is that even though there are two USBs here, neither of them is actually the native USB, which is like so unfortunate. Cannot tell you how unfortunate it is. But I do have this cable here that you can get off Adafruit. It's just a regular USB-A 2.0 to just the 4 wires here. And we should be able to figure out where we can plug these in so that we can get native USB support as well. But we don't actually have to do that right at the start. Okay, so it looks like this jumper for the RGB LED, let me go back to my desktop. This jumper for the RGB LED is included and on by default. So I think because of that, we want it to work by default in CircuitPython as well. These are available from Adafruit for $55. You might be able to find them cheaper elsewhere, but I'm not sure. I haven't looked. I got this for free from Espressive, so disclaimer. I would have bought it myself. Wait, did I buy it? You know, I think I might have bought it. I don't remember. I might have bought it from DigiKey. I knew I was going to need it either way. I did get at least one Sala from them. But yeah, so let's go back to our guide. And we set our initial configuration, and now we're on initial build. So right before we do that, let's actually change this to 45 here. David says, mine came from DigiKey too. Awesome. Okay, so we've copied another board. We can just skim here. Debug UART is probably the same. This is all the same, although we can change the USB product as well. Kaluga 1. We're going to have to update the USB Pid, which I think is covered in the guide. We'll get there. Okay, so let's get on to building. So it says, okay, once you've done that simple thing, let's make sure that that worked. So we're going to do make, and it's a bit more difficult. Let's just, I'm going to cheat and find a older version, hopefully. Yeah. This is what I want. So this is the older command line I used. So I'm just going to rename it Kaluga 1. And I'm actually going to plug it in as well. Oh, you know what? I can switch desktop to overhead. So I'm just going to use one of these short... Actually, I could use this one. Going to use this, and I'm just going to plug it in. And I'm plugging it in to the one labeled USB. And it looks like there's a power switch as well. And it looks like there's an arrow here. So I'm just going to flip it on. And that still didn't turn anything on. So hopefully it works. We shall see. So we're going to build it, and it won't load it yet, but once we build, we can flash it. Okay, so it's complaining about Python. I have a different, or I don't have a virtual environment at all. So to do that, you go to the ESP you do export IDF path. This will change a little bit if you're on Bash, because I'm on Fish. And then I do export Fish. If you haven't done this before, you'll want to see, I'm switching between things. Yeah, it's annoying. Let me show you what you're gonna do. Install, you'll run install. And now you should be able to run export. And it should be all set up. So if you haven't done it before, you'll run install. It will download like GCC and GDB and all that stuff. And then you export to get it in your environment. So now if we go back to build, I'm just hitting up to get to the previous things. If a build fails, it's possible the next build will fail too, because the intermediate state might be wrong. So if in this, basically whenever a build fails for an unknown reason, I recommend cleaning and then doing it again. Oh, David points out, do you need the other USB power port connected for power supply for the board? Ah, maybe. Yeah, maybe I have to have it and no power ever comes from the other one, which is kind of wild. I don't have any longer. I don't have any more long. Wait, yeah, I do. I try to keep all the USB cables on my desk really short. So let me just plug in a power one here. Ah, there we go. Thank you, David. So now we have a green light. It's labeled STB. There's also a red light over here. So, okay, so the build finished. All okay. So this is the first step. And the reason that it works, even though we haven't kind of changed anything but the core stuff for the boards, is that there's only a few critical things to getting CircuitPython started. Like getting the crystal right, getting the SPI flash right will prevent CircuitPython from starting. But everything after that is really like a bonus. So if you've used CircuitPython before and you do import board, you do board.name, like that stuff's all nice. It doesn't prevent CircuitPython from actually running though. Which is why you can really get to that like build and load step pretty early. So let's load it. Me6 says, hello all. Just when I get a Sala board to play along at home, we move to the Kaluga. Sala's a great board still. Okay, so let's flash it. Yep, Bruce says, put J4 jumper on if you want to control the RGB. Yes, I do. Doesn't look like we have any USB though. So I'm just unplugging and replugging in this second USB. No luck. I wonder if it's a different converter chip. Do I need a... It might be. I might not have a driver. Do I not have the driver? Welcome to Deep Dives. So ACM0 is my keyboard, so I'm not going to fuss with that. Let's look at my errors. It's using an FTDI, not a CP210X. How do I get an Ftdi working on Linux? Yeah, it's definitely an Ftdi. Like, this chip is really giant. Should it just work? I don't see. I could try a different USB cable. Let me just swap and see if that helps. So because the way this works, it is talking to, okay, so the blue light went from on to off. JTAG switched to on to enable connection between the ESP32-S2 and the Ft32-S2. Okay, JTAG switched to on. Okay, so is it all of them? There's 8 here. So I've got my tweezers. I'll switch to the overhead so you can have a chance to. The block diagram seems to indicate shared JTAG and USB. All right, let's take a look at what David's looking at here. So in the schematic, how to install Ftdi drivers on Linux. I really don't want to. I could actually do Arch Linux Ftdi. If I have to restart, I'm going to be upset. Oh, you know what? I did have to do these UDEV rules for other things. I had to do UDEV rules. Ftdi drivers are nice. Let's see, LS USB. Okay, so it's not even seeing the device. So, like, I think David's on the right track. The module. Pin configuration for subboard. FPC. There's a different ESP prog connector for their ESP prog device, which I actually do have. I did get one of those. Switch for JTAG. Default is JTAG off, no connect. Switch on for JTAG debug. USB power and communication, Ft232. USB D+, D-. Auto program. Can you search the schematic for JTAG? Power charging. I think you're talking about this JTAG switch, right? Switch on for JTAG debug. But it doesn't do... This JTAG debug does not do UART still. Huh. Although there's this... Yeah, it looks like the UART should be connected. It's just not... Like, JTAG is not. Which should be okay, because we should be able to load over JTAG. Yeah, so that's probably okay. I'm surprised we don't see it in LS USB, and we didn't see it in... No, I didn't see anything in dmessage. So the other thing we can try to do is we could try to... Oh, you know what? We could do the boot reset trick. So I'm holding boot. Let me hit reset. and then see if that did anything. See, like dmessage doesn't show anything. I don't know a lot about the FTDI stuff. LSUSB, unless this is it, which is blank, but it usually shows up as an FTDI thing. Yes, FTDI should just work on Linux. That's what I thought. I need to get it to find the device first. Here it showed instantly, Bruce says. I wonder if mine's a dud. It's possible mine's not working. Or it's possible I like flipped some switches I was not supposed to. Oh, you know what? You know what we had trouble with is like we had trouble with this hub. Let me just flip the hub off and on again. The data wires to the USB is connected to a cable that doesn't have a switch. Okay, let's see if that did it. There we go. I don't know what's with that hub. So we got that, and now we've got LSUSB. We've got 2 there, which is good. I don't know which one is which. Let's see what dmessage shows. And it says that it's on both. So, okay, right, I think we're good. I'm glad I did that. Let's just try flashing and see if it just happens to work. Doesn't look like it. It's possible we're talking to the wrong one. That doesn't look promising. I wonder if it's USB 1. Timed out waiting for packet header. There we go. Look at that. I know, like, what's with that hub? Like, it's a pluggable hub. I don't know why it's I don't know why it's so finicky now. That happened last week, didn't it? Like last week we had that problem too. Bin the hub. I know, like, but I like this hub. I would just buy another one of them, which I probably shouldn't. It must be some interaction with Linux, like it gets in a bad state and then it's no good. Okay, so we flashed, which is awesome. And then, I don't know if you can see it. It's kind of hard to see. Can I? Yeah, there you can kind of see it. That it's actually the green RGB LED is ramping up and down, which is actually what CircuitPython would do if it was loaded and finished correctly. Oh. So that actually looks super promising. Let's try to connect to the native USB. So it says here you need to hand wire D19 and D20 to the D plus and D minus pads. And I have this data cable. So that's D19 and D20. And plus is green. Okay. Let's figure out how to plug this in. Folknology says the hub will drive you mad eventually. Yeah, you're right. It will. Okay, so 5 volts. I might need longer. Where are 19 and 20? So 19 and 20 over here. Do you think I can get away with not connecting the 5 volts? I bet I can. As long as I connect ground. Which is actually definitely not very easily accessible either. So I'll just, oh, let me switch to overhead. Okay, so I'm gonna plug ground into just a longer cable. And then actually just gonna plug it in right here. Does that make sense? Yeah, if we try to put a hat on here, it's not gonna fit for one. Maybe it will. Actually it will, because the the expansion boards go off here. Oops, sorry. Don't connect the red wire. Okay, I won't. It sounds like a bomb defusal sort of statement. Okay, so we decided green was plus, and plus goes to... Green is plus, and plus goes to 19. So there. And white then goes on the 20. Right? This is why I love streaming. Hey, Johnny. I talked about unit tests earlier when you were not on here. Okay, so those two are connected. Let's see if we can't get... Oh, no, well, it would help if I plugged it in, wouldn't it? So I'm plugging in the USB-A side into my hub that doesn't like me. So let's take a look at our dev TTY ACMs. Oh, we only have 0, which is not good. I think I'm connected correctly. So I wonder if I just hit, actually, let's see what USB is. So those two still. Sudo dmessage. It gave us a bunch of errors. That's not good. So I'm a little worried that I don't know how well routed the USB signals are. But let me just hit reset again and see if it isn't happier. Yeah, no luck there. So one thing we can also do is if we do screen and then USB 1, we should be able to see. It's the hub. It could be. Bruce, did yours work? If you tried that? Okay. The other thing I know I can do is, so usually this is not part of the hard part of making a new board, because new boards typically have native USB connected directly to a USB connector. Okay, Bruce says he's just about to flash it. So I'm going to just reload CircuitPython on it, and then I'm going to immediately jump into screen to see what it has to say. Are D plus and D minus connected right? I think so, but maybe not. I have... So the connector is too wide, but I think each one in the connector is connected to the same thing. So like each row here is connected to the same thing. And so I've got green to 19 and white to 20. Is that not right? I could flip them and see. So it says starting scheduler. I should put a message here that just says like, oh, I'm starting CircuitPython. But like the LED is ripping. Like CircuitPython is running. Lolatron says I would test that to make sure with a multimeter. Let's take a look at our... Did it come up then? No, it didn't. Just had a bunch of errors still. What's on the schematic? Let us see. Let's see if those two. Oh, see here, EXT, GPIO 19 and 20 are connected to one of the USBs, but it's ground is connected. I think so. I mean, it's through a header here, but it looks right. I could try another spot. I wonder, does it need 5 volts connected? I can connect 5 volts. I wonder if the hub is smart enough to know whether it's drawing power or not. Although it shouldn't draw power. This is why they should have put native USB on it. Then we wouldn't have to fuss with it. There's 2 resistors I could solder down. Or maybe the resistors are placed. Is that possible? It's connected to J10. Unfortunately, J10 is not labeled. There are test points for D plus and D minus near the NC resistors connected to the OTG lines. I don't see... Oh, the resistors are probably the vertical ones. Those are way too tiny. I mean, I've got... I could just try it. Do you think it's through the battery connector? Or... No, definitely not, because it's alternating between the FTDI and the native one. Cucumber. It isn't currently wired. Right, and then this is the power version. Wait, no, J11 goes to USB plus, USB minus. And then it just goes to test point 7, test point 8. Right, so that's what the test points are. Unfortunately. So it does look like J19 and 20 are on both sides of there. I did plug in the 5 volts on the cell though when I was doing it natively. I should just do that. Is it confusing if I use a black wire? I think there is no pull-up on D+. It needs a pull-up? I just plugged it in. I just plugged it in with the... Let me plug in the 5 volts. I will plug in the 5 volts to a thing labeled 5 volts. Okay. You could disconnect the FTDI cable. Yeah, but I like having them both there. I'm just like, sorry if you wanted a concise way of doing this. This is a perfect example of how a deep dive goes. I think I picked up something simple and then we hit the weeds. We hit a bug. We hit a snag. But that's like classic classic deep dive stuff. Yeah, pull-ups are a part of the chip, not something you want fixed. So dmessage didn't show anything, which it should. List USB. I think I should blip the hub again. I could. 5 volts. You know, since it's coming up, I wonder if we'll power it through there. Let's just do that. We'll hit reset. And you can't see my screen. I'm sorry about that. Ah, it still didn't work. Yep. Sorry, David. Yeah, it is pretty old. I just never got around to adding support for it. It hates me. Do you think I just flipped it? What? I'm just gonna flip it. I'm flipping D plus and D minus. Hopefully that won't destroy things. Like, CircuitPython's definitely running. We're doing it live. Like, the NeoPixel, like the RGB LED is definitely correct for CircuitPython successfully running. It's just that, yeah, okay, so I flipped the D plus and D minus, and now we're not getting anything out of it. Okay. If I switch it back, like the ground I'm connecting to is way far away from. Trying to think if there's any other spots that I can put it. But no, I don't think so. Those are the only spots that they're broken out. I'm running out of ideas. Hey, Remy. Says, I'm the guy with the Nano ESP32-S2. I showed your tweet earlier. I'm trying to add this board in CircuitPython. I managed to compile it just now. Seems like a lot easier than this board. Yep. I picked a hard one. Have you got the right pins? Yeah, I think it's just not working. I don't know if native USB will. I would love to. I know Bruce was working on it. Like, I would love to hear. Doesn't sound like, yeah, Bruce doesn't have the USB breakout, unfortunately. So Tito asks, refresh me on why pin 19 and 20. Those are the 2 pins that are explicitly designated by the module and the microcontroller as USB plus and minus. Like USB has special driving, so those typically on a microcontroller there's only 2 specific pins that you have to use. Green is 100% GPIO 20. What? 100% GPIO 20. I have it backwards then. But it didn't work at all. It didn't even fail to work when I had it that way. Let's see if Lady Ada's around. She has one too that she could try. Let's triple check that. So this says D20 is D minus. There's a set of jumpers. Did you see them? Saw the JTAG ones. Could flash through. Yeah, I did see that. Oh, you're thinking the names are wrong? DP equals 20. Oh. So this is confusingly worded. Here, I think I could slide this over. So this is the internal Slack. And Lady Ada just sent me the same exact picture that Mark is sending me. Telling me 20 is definitely D+, as Mark is saying. Okay, and we decided that was green, right? Yeah, green. Okay. I'm wrong then. Why doesn't it show up at all then? Okay, and I'm gonna hit reset for good measure. I might have to, I'll just blip my hub. Since it, did I remove my hub now? No, I didn't. I'll just turn it off and back on again. I'm not gonna run 7 cables up from my computer under the desk. Hey! It popped up. I don't know what's with this hub. Okay, great. Yay! Okay, I'll let her know I got it. Confused by the product copy. Whether which pin was D+ or D-. Drop notes in the chat about your recommended USB hub. Right now it's a pluggable 7-port with charging. Tito, it was one. There was 2 things wrong. One was I flipped the wires, so D+ is actually 20, which is green, so green to 20, and then that didn't work. Like it had no error messages, but I think that was because of the hub. So I turned the hub off and on again. Okay. Whew. Welcome to Deep Dive if you thought that it would be simple to add a board. I'm pretty sure I said that earlier, but we're in the home stretch. So let's go back to our guide, which we do have here. Everybody hates this hub. Should I go like Office Space on the hub? Okay, so we did this. We built it. We loaded it. We don't have UF2 yet, so we won't do that. And then from the REPL, try the following. So let's do that. We're in the REPL. We can do import microcontroller, if I can type it right. And then, what's it say? It says dir microcontroller.pin. Mark, I owe you a lot of coffees. We know that. At least it wasn't looking at the examples this time. Okay, so this is where we start. And this is the reason that like everything else is a bonus for CircuitPython, is that you can actually access the pins from the microcontroller's perspective kind of by default. And then the nice thing that you do is you then, yeah, David says, aren't 7-port hubs really 2 4-port hubs? Yes, usually. And they're daisy chained, so I definitely had that problem before. But yeah, I could look into 2 4-port hubs. That might be easier to manage as well. Okay, so Timon says, I generally recommend USB 2.0 hubs. In my experience from doing long-term exhibits, they are a lot less finicky. USB 3.0 still has lots of bugs in Linux. Ah. Yeah, Mark, I saw Mark made a PR to add the or to fix the theme. Ooh, fix the theme. Nice. What did you change? Okay. Neat. Mark, you're awesome. Okay. Quick aside, sorry for folks that were like, I just want to add my board. Okay, so we did this. Now let's go to this step. What did I? Oh, I got emails about what I just did on the PR. Let's see, what does it say? It walks you through each file and how to update it. So np config board is where we're starting. So let's pull that up. And it says board name, MCU name. Auto reset delay is like, we have it for every board and it's literally the same for all of them. But let's see what it says. This file contains the board name, the MCU name, the status LED pins, which we already have working, flash size, which you already have, and ignored pins. So ignored pins is just an optimization if you have like a very small SAMD21. Ignored pins prevents it from showing into the microcontroller.pin thing. And then default I2C, SPI, and UART bus pins, which we obviously haven't done here. So we're just going to leave those. We're going to leave these. We could skip those, but I don't care. Okay, so pins.c is where a lot of the magic happens. This is what maps between the microcontroller.pin module and the board module. So it's actually really nice to do like friendly names, specifically the names that are on the device in the pins module. So I'm actually, let's just skip around. Chip variant we did. So before I get to pins, let's talk about this other stuff. So the lines for npconfigboard.make, the things you want to update are the VID, the PID, the product, and the manufacturer. So let's take a look at that. Manufacturer is Espressif, USB products Kaluga 1. Let's see what D plus is 20 and green in our breakout. Lamore is going to update the oh, you know what I should use? I actually have, this is what I should be using. Instead it's sitting on my desk. But I actually have the you can't see. The Capable Robots USB hub that actually runs CircuitPython. That's what I should do. Yes. I like the rolling eyes. Okay, so this is all correct because it's the same module. This stays the same. The one thing we're going to need is USB PID. So let's, this is something very important to cover because this is by far the thing that people always have to get corrected on board pull requests. So how do you get a USB PID? So the USB consortium charges $5,000 a year, I think, for a USB VID. So VID is vendor ID. So this 239A is specific to Adafruit. So let's see what it says here. It says USB VID and PR is something you cannot borrow from another board. And the reason for that is that we want the computer to be able to tell the difference between a Sala and a Kaluga and a such and such, right? So we want different boards to have different USB IDs. And we actually go a step further. We don't want like Arduino on a Kaluga to have the same USB as same PID as CircuitPython on the board as well. So it says, so don't copy and paste these values. If you don't have a VID-PID pair, open an issue in CircuitPython repository and request one. We will assist in the process of assigning a PID for you to use with CircuitPython. So Mark says, I can't believe you had that. Yeah, the hub. I think I was actually having problems with that hub too, but that was with Mac, so I should update it and do all that. So yeah, I should try that again. So there's a couple kind of rules of thumb about USBs, USB PIDs. One, if you're a maker and just doing it for fun and want to run CircuitPython on it, we're happy to give you PIDs. We actually give 3. We give one for the bootloader, one for the bootloader, one for the Arduino, and one for CircuitPython. Killer Geek says there are 7-port USB hub chips, but most use the cheaper option with the 2x4 port hubs. Yeah, but I bet the 7-port USB hub still connects one downstream from the other. All right, we're 10 minutes in, so maybe I'll just start the pin stuff. But this USB stuff is really important. If you are a company that has lots of products, we kind of we do expect you to have your own VID if you're making lots of stuff with the USB. And then it's up to you to decide what the PID is. But if you're adding a board definition for a different company, then you could ask us for a copy of one. So that's one of the biggest hurdles to getting stuff in, is just getting assigned a VID-PID pair. There is also this pid.codes site that allows you to kind of share within some other stuff, but they haven't been very responsive on the pull request lately. So that's another option as well. But generally, you can just open an issue and we'll get you on. Unless you're a company, then we think you should support the USB stuff with purchasing a vendor ID of your own. Okay, so that's the deal with the USBs. Board.c is board-specific initialization. So let's just do... Yeah, we could actually skip the pin stuff now. So for board-specific initialization, this is just telling it what pins to never touch. And it will also automatically not touch the pins that are used for like the SPI flash and things. Otherwise, CircuitPython tries to be pretty aggressive in like resetting pins to their default state. So you'd be aware of that. And then we want to do this GitHub workflows build YAML. And so let's just do that right now. So at the top level, it's CircuitPython and then GitHub workflows. And you can see it, good. Build.yml. This is a big long file with these big long lists. There are separate lists for different platforms. So this is for all the ARM boards here. So we'll just go down further until we'll get to the build extensa. And now you have to put it alphabetically. I added a check so that it is. It will complain to you if it's not alphabetical, because it's way easier to look through a list of alphabetically sorted things. So I'm adding that there. Bootloader, we're not doing that stuff yet. And then submit a pull request. Let's see. How am I doing on time? Let me just do some pin stuff, and then we can make a pull request. there's actually two steps, like a couple bigger steps. There's the pull request stuff, and then there's also a second follow-up guide that you should follow, which is how to add the new board to CircuitPython.org. So the list I showed earlier of CircuitPython.org/downloads, that is something we want you to add too. And it's actually kind of a pain if it doesn't get added immediately, because if we do a release and the board's there, it ends up in like this weird like unknown board in that list, which is unfortunate. So I'm not going to do this today, but be aware of it if you're adding your own board. Let's just take a little bit of time to talk about pins. There's a lot of pins, so I'm not going to do them all. Unfortunately, all that USB stuff really hung me up, but let's go over this. So this is actually a great start here, because the Sala breaks out the pins and it gives them the same name. So what is the structure of this file? Yay! Me6 says blinky green CircuitPython goodness on the Nano board, I think. Yeah, so these names are all the same, which gives us a huge boost. So the names that we want to go by are, like the names on the board. So first thing is, so the names on the right in this list, let me go back. The names on the right in this list, this is a table. Think of it as a table, like a CSV file or a spreadsheet, right? There's two columns. The left column here is the friendly name, the board-specific friendly name. And then the right column is the name of the like internal microcontroller view of the world, the microcontroller's names of those pins. In this case, where we have a module, we actually like ignore the name the module has for things. We just refer to like the microcontroller and the board. So we really have this standard set here, but you can see that we actually have a little bit more of an option. You can have repeated entries. Because this is just a table mapping, you can actually have more than one name on the left mapped to the like microcontroller view of the pin on the right hand side. So if you, the kind of standard practice here is to have the first name in this list that matches is the one that will print out when you print the pin object. So the first one should be kind of your default, and then all of the ones after that are kind of aliases that will work as well. So one thing we want to change is this actual NeoPixel one, right, is different. So on this board, it's at 45. So we're going to want to change that. But then I think everything else, like all of these headers here are actually just IO whatever. So they're the same. And they're the same here as well. Where it gets really interesting is not actually their IO here too. But I think that the thing that would be really helpful is actually the names that are for the example, or for the external boards. So if we pull up the schematic, let me just show how to do this. Say we want to do the display. Well, the display is a complicated thing. Getting the display working by default is maybe not what we want, because it is something that you can take on and off. But we should at least provide like friendly names for that so that it's easier to initialize. So looking through other boards is actually a great way to figure out like standard names for things. So like the way that we have, so this Q string stuff is all boilerplate. The string that you're actually going to get is anything that's after this. So there is a board.neopixel that we get here. The spreadsheet has the pins as well. Does it have other names for it too? So David G asks, so the Kaluga will be in 6.0 Alpha 4 since Alpha 3 is just out. Yes, it should be in the next release, assuming that everything gets in. I think the next release will probably be beta 0 though, not alpha 4. And I think we're hoping to do that next week. We're trying to be, we want to be a bit more aggressive. Excel. I don't have Excel. I can't do that right now. Sorry. So what was the example? So one thing we could do is we could do these camera pins. So if you see here, there's actually just like a very similar style of a mapping thing. Like GPIO 1 is camera X clock. So what we could do here, I can't squeeze that on the end. Yeah, let me show, since I'm here, let me show this stuff. Let me go vertical. Let me just show that this works, and then we'll call it a day. So let's add all of these camera names. So I'm just gonna, the way that I'm gonna do it is I'm just gonna copy, and I'm gonna put it after, because actually maybe I want this separate. Maybe I don't want to intermingle then. So let's make a separate one, and let's just call this camera X clock, and that's GPIO 1. Mark says it's time for a 1 a.m. snack. Okay. GPIO 33. Ah, this is bringing back, like, giving me deja vu. I've definitely done this on on a deep dive before. When you all taught me, like, how to, like, not use the mouse for everything. Ooh, brie and crackers. You're making me hungry. You want me to wrap up sooner? Is that what it is? VSync is 2. Let's see here. So 7 is connected to SIOC by default. Now I'm going to go by what's default here. Oops. SIOD. Oops. D is 8. C is 7. And then we'll just have to do D. D2 through D9? That's like, that seems like a little bit weird. Why is that? 46. D2. You're talking about food. You realize I get hangry, right? If I'm too hungry, I get irritable. Irritable is a nice way to say it. 45, 41. 4. Let's see. 41, 42. I'm going backwards. 39. 40. 21, 38. 21, 38. 5, 6, 7, 8, 9. Okay, so that's just a brief overview of how pins can do. Let's just rebuild and load, and we'll see that we have. If we import board here, oh, Bruce is giving me screenshots. That's nice. And we do dir board. This is what we currently have. My voice is tired too. So I disconnected, and let's flash and reconnect, except we're not actually plugged in now. We are still powered, although I wonder if the Ftdi is powered. It's not. So I'm plugging in 2 more USBs and gonna flash it again. Our local baker is only Wednesday through Sunday now. Ooh, nice homemade roasted garlic butter. I'm definitely gonna go have a snack. Multiple cursors, yeah. My brain is not up for it right now. David says this might be a good point to mention the magic of MPQ strings. This confused me in the past. I remember you doing this before, but I'm also glad it makes more sense the second time. Cool. I have a lot of USBs plugged in. Let me tell you. David, did I cover the MPQ string stuff, or should I reiterate it? Why are you putting pictures of food in the chat? That's like very cruel. Like I'm very hungry. I'll definitely go get some hummus. Have a hummus snack. Actually, there's zucchini muffins that my wife made. All right, we're started up. Can we screen to it? No. It's really unhappy with that, isn't it? Oh, no, it's there now. Okay, so now if we import board, we can do board dot. We could tab, and now we can see that all the camera stuff is there. The other way we did it is we did dir board. But yeah, I don't know. Did people know that you could do tab complete? It's really handy. So you can do like camera, and then you can see just the camera ones. David says, I tried to understand QString before I had the build tools running, so I had to guess what it did because I couldn't just search for it. Yeah. Trader Joe's garlic naan. Mm. Oh, on with a slice of cheese and ham. You all are making me hungry. Okay, I'll make a pull request even though it's not done, just to show that process. So I can leave that open, that'll work. So if we do git status, which you should always do when you're starting to do git stuff, and then I'm going to add the boards, and I'm going to add the GitHub workflow. And you can see my screen. So now if we do git status again, we can see that we added all the files there, and we, the other thing we should check is that the memory is working. gc.memfree. We should have the 2 megabytes, which we do because the module has it, and we copied it from the other stuff. Me6 says, so I've followed these steps for the Gravitech Cucumber R S2 board. However, Gravitech doesn't seem to have a USB VID of their own. Yeah, if you're doing it on their behalf, we're happy to give PIDs to them. But if they were doing it themselves, we should ask them. But yeah, we've actually also discussed getting a separate VID just for CircuitPython. We'll see. Okay, so everything's staged. Let's just commit it. Add Kaluga board. Board definition. Oh, and you know what? I didn't change the VID yet, so I will actually mark it as a draft when I create the pull request. But I can push like so. And now if I go to Adafruit CircuitPython. Yep. Yeah, you can raise a PR and just say that it's not quite ready. So if we refresh, it shows up with this yellow box, which is super handy. and add Kaluga board definition. And where do we, is it in this dropdown? Create pull request. Create draft pull request. And I don't think you can add labels, but I'm just going to add a label here that says enhancement to the S2. And we'll set the 6.0 milestone. 6x feature. Anything on 6.0 milestone should like actually block it. Yeah. Yeah, I mean, I would love to see USB VIDs be way easier to acquire. 5K a year is a lot. Although somebody pointed out that like you could do it for a year and then keep using it, even though they don't want you to do that. They're not about to give away a VID again. I'm digging myself a hole. Oh, my face camera is frozen, isn't it? I switched back to it away from the overhead. Thoughtful and focused. Yeah, it's like talking about USB. Let me tell you. Since I haven't wrapped up, let me climb under my desk and re-plug it in. Let's see. No. Cat cam it is. The kitty's actually there. She's looking at me. Kitty. Okay, let's finish the PR and then I'll move the cat cam. And I'll just, that one's still working. He thought I was meditating. I was sitting very still. Yeah, USB on Linux it's not super happy. So just taking a look at this stuff, this is all the same boilerplate stuff. And I could actually add a to-do. Need to add remaining pin names and add change USB Pid. And I'll click draft pull request. If you were completely ready, you could just say regular pull request. But for now, that's where all I'm gonna do. And let me move cat cam because USB 3 in Linux, I guess, is never good. I could like use the hover cam for it too. Thank you for pointing out that was frozen. Okay. Nice. I have contemplative me. I have contemplative me there. It's actually kind of nice having like this is more than one time that cat cam has like saved me from it. Here I can make this one hover cam. Oh, that's not gonna work. That didn't work either. Let's turn it off. Boom. Okay, thank you everybody. This has been another deep dive. It looks like we actually got one reviewer already. Tito approved the changes, so thank you for that. This has been another deep dive. I hope that I'm sorry that I got lost in the weeds of getting USB going on the board. It would have been a lot shorter to get a board going, but still it was still just over an hour and a half, which is really not that bad compared to adding a new port, which is a lot more work. So I hope to see more ESP32-S2 boards added to CircuitPython. I suspect there is going to be a lot of them. Really excited to see them come in, see that list grow to 150 and beyond boards supported with CircuitPython. Yeah, very exciting. Gonna blow my mind, I think, actually. I hope this video was helpful in figuring out how to do that. The guides are there. I will try to put... oh no, I think we're getting a meme out of this. I will try to put links in the description to the YouTube video, to the resources here. I don't usually do that, but I really should be better about it. So I'll try to do that and get resources out for there. I said I was going to split the video out, but I may not, just because all of that USB stuff was quite the side track. So I'll think about that and get some opinions. Let me know if you think it's still worth me splitting out. Otherwise, we could just time code it. Yeah, I was hoping to do it in more like 30 minutes to an hour, not an hour and a half. But yeah, so I hope for those of you who have boards, it made it clear kind of what the process to get going is. What was happening on here is that there's... I was wrapping up and then I was going to point something else out. But, yeah, all of the boards are building. So once you have a PR, even if it's a draft, it will make sure that all of the boards build, including the board that you just added. So we'll definitely want to see that. That means that it goes into the S3 bucket and everybody can get it as soon as it's merged into main. Before that, you can actually snag it off of the PR as well. Maybe I should just show that. Okay. Sorry, I'm not wrapping up. I don't have a desktop plus cat cam. Sorry, you get concentrated me again. So this is the PR. It's running 3 checks here. But what you can actually do is if a PR is done, you'll be able to get artifacts from it. Let me see if I can just show you an example. So if you wanted like native Wi-Fi, you can actually grab the builds even before they hit S3. So just pull up the checks. Oh yeah, I need food too. So up in the top right here, there's this artifacts, and then it's listed by board. So if you ever want to test a PR on a board that you've got, you can always snag it here. And I think it is alphabetical, so we can see that there's like 2 Espressif boards here. And that's a zip file of all the different languages for the given board. So yeah, I guess with that, thank you so much for hanging out. Reminder, housekeeping reminder sort of thing. Next week will be on Thursday, not Friday. I'll try to post earlier about that. It'll be Thursday at 2, not Friday at 2, because I'm taking Friday off. The week after that is CircuitPython Day on Wednesday, and so I'll be streaming on CircuitPython Day, not on Friday of that week. So the next 2 weeks are not on my normal Friday at 2 p.m. time. They'll be earlier than that, so just heads up. We are also doing the CircuitPython weekly meeting next week on Monday, but the following week on Wednesday as well. So we're kind of lumping all our CircuitPython stuff on one day, which should be very exciting. And I'll try to come up with something exciting from that as well. We'll see. Anyway, thank you again so much, and thanks to those folks adding new boards. Thanks for hanging out, and I'll see you next week on Thursday. And you can't see me, of course. I will see you next week on Thursday, even if you can't see me.